to discuss about a very interesting topic of a complex analysis, means zeros and singular points. Then we discuss about the residue. So first we define the zeros, then singular points and types of singularity, and what is the relation between zeros and singular points, basically zeros and poles. So what is the zeros? So first we define the zeros. Zeros of not a zero, basically zeros of a analytic function. If fz is analytic at z equals z0, then z0 is called zeros of order 1. Zeros of order 1 are simple zeros. Zeros is called zeros of order 1 are simple zeros if f of z 0 equal to 0 and f dash z 0 does not equal to 0. This one is what? This one is a definition of zeros. So this one is a zeros of order 1 are simple zeros. So similarly, we define z0 is zeros of order m if f of z0 equal to 0. Similarly, f dash z0 equal f double dash z0 up to fm minus 1 z0 equal to 0. But what will happen? But f nth order of a z at z equals z0 does not equal to 0. Does not equal to 0, then we say that fz have a zeros of order m at z equal z0. So for example, here if we write fz equal e to power z minus 1, e to power z minus 1. So here this function is what? This function is analytic. Fz equal e to power z minus 1, this one is analytic everywhere. So what is the definition? Fz is analytic at z equals 0. So here we check at z equals 0, what is the zeros? Zeros of order 1 or zeros of order 2 or zeros of order 3. Now first condition is about fz is analytic at z equal 0. Since fz is analytic everywhere in an entire complex plane, so at z equals 0, fz is analytic. Now what is the value of f of 0? F of 0 equal what? E to power 0 minus 1, this become 1 minus 1, this one equal 0. What is the meaning of this one? f0 equal to 0. This one is the zeros of order 1 if f dash 0 does not equal to 0. So what is the value of f dash z? F dash z become what? E to power z. Now what is the value of f dash 0? F dash 0, this become e to power 0. This one is a 1 and this one does not equal to 0. So what we say that z equals 0 with a zeros of order 1 of fz. Z equals 0 with a 0 of order 1. Now if we define this one in a more systematic way, means what is the value of fz, we try to define it, we try to write this one. Since fz is analytic at z equals z0. So what we'll here write, fz equals z, fz is what? Fz is analytic at z equals 0. So if we erase out this one, and try to write what? Here fz is what? Fz is analytic at z equals 0. So if fz is, what is the basic condition? Fz is analytic at z equals z0. Then what will happen? And here also we assume that z equal, this one is fz is analytic at z equals 0, and at z equals z0 there is a zeros of at z equals 0 there is a zeros of order m, zeros of order m, zeros of order m. Then what will happen? Zeros of order m, then f dash at 0 equals 0, f double dash at 0 equals 0, f m minus 1 z 0 equals 0. Since fz is analytic at z equals z0, then we able to write what? We able to write fz as a Lorentz series expansion, as a power series. So now how we write this one? Fz is analytic at z equals z0, then fz can be written as a Taylor series. And here this become what? Summation n equals 0 to infinite an z minus z0 to power n, and an is a what? Fn z0 divided by factorial n. Now if we write this one in terms of a derivative, what is the value for this one? Fz can be written as what? Fz equal, what is the value? Value become f of z0 plus z minus z0, f dash z0 divided by factorial 1 plus z minus z0 whole square, f double dash z0 divided by factorial 2. Now similarly, if we write a what? If we write a mth term, this becomes z minus z0 to power m. Mth derivative at z0 divided by what? Divided by factorial m. Similarly, next term is the what? Z minus z0 to power m plus 1 divided by factorial m plus 1, m plus 1th derivative at z equals z0, and how many number of terms? There is infinite number of terms. So, since z equals z0 is the zeros of order m, then what will happen? This term fz0 equals 0, f dash z0 equals 0, f double dash z0 equals 0. Similarly, fm minus 1 z0 equals 0. So here if we write, since z equals z0 is zeros of order m, then what will happen? Then fz0 equal f dash z0 equal f double dash z0 up to fm minus 1 z0 equal what? 0. So if we put these values here, then what will happen? Fz become what? Fz become fz equal z minus z0 to power m, mth derivative at z equal z0 divided by factorial m plus next term z minus z0 to power m plus 1, m plus 1th derivative at z equal z0 divided by what? Factorial m plus 1, and how many number of terms? There is an infinite number of terms. So if we simplify this one, then fz become what? Fz become z minus z0 to power m outside. Now inside what will happen? Inside mth derivative at z equals z0 divided by what? Factorial m plus z minus z0 fm plus 1 z0 divided by what? Divided by factorial m plus 1 and how many number of terms? Infinite number of terms. So if we closely observe this one, you may write this one as like this one, fz equal z minus z0 to the power m, and this one is a cz0. cz0. And what is the value of a gz0? This one is a gz0. This one is a gz0. So if we erase out this one, and here we write, and if we closely observe this expression, what is the value of a gz0? gz0 equal this one. This one is a gz0. This one is a gz0. This one is a gz0. So fm z0 does not equal to 0 and m is a positive number, so this one does not equal to 0. So what we conclude? We conclude that gz0 does not equal to 0. So what here we write? Fz equal what? Z minus z0 to power m cz0 provided gz0 does not equal to 0, then we say that what? Fz have a zeros of order m at z equals z0. If we able to write any function in this form, if a given function can be written in this form, fz equals z minus z0 to power m gz0 provided gz0 does not equal to 0, then we say that at z equal z0 function have a zeros of order m. And what is the initial condition? Initial condition is that fz is analytic at z equal z0. So this one is the equivalent definition of this one. z0 is the zeros of order m if fz0, f double dash 0, fm minus 1 z0 equal to 0 and fm z0 does not equal to 0. Either in this form, or if we write the fz, if fz is analytic at z equals z0, if we write in this form and z minus z0 to power m, then we say that function have a zeros of order m provided what? gz0 does not equal to 0. Now let us take one example to elaborate this definition, this concept. So suppose here we take fz equal what? Fz equal, example, fz equal what? Fz equal z into e to power z minus 1. Suppose this one is fz. If this one is fz, now this one is analytic everywhere. Now we try to examine the order of a zero at z equals 0. At z equals 0, what is the order of a zeros? Order of 0. Order of a 0. So since fz is analytic everywhere, so this one is analytic at z equal 0 also. So what is the solution? This have a mth order if mth derivative at z equals 0 does not equal to 0 and all previous derivative at z equal to z0 equal to 0. So what do you predict here? Fz equals this one, fz equals z into e to power z minus 1. What is the value of f of 0? F of 0 equal to what? F of 0 is a 0 because 0 multiplied by e to power 0 minus 1, so this become what? 0. What is the value of f dash z? F dash z is a what? Derivative of this one, derivative of means a z into derivative of e to power z minus 1, this become e to power z plus derivative of this one and e to power z minus 1. This one is a what? This one is f dash z. Now what is the value of f dash 0? F dash 0 is again 0 because 0 into e to power 0, this one is a 0 into e to power 0 plus e to power 0 minus 1 and this one is a what? This one is a 0. This one is a 0. This one is a 0. Means f0 equals 0, f dash 0 equal to 0. Now what will happen? F double dash z, this one is a what? This one become z into e to power z plus e to power z and plus e to power z. Now what is the value at z equals 0? F double dash 0 equal what? This one becomes 0, e to power 0, e to power 0, this becomes 2, and this one does not equal to 0. So what we conclude here, since fz is analytic and z equals 0, f0 equals 0, f dash 0 equals 0, but f double dash 0 does not equal to 0, then we say that what? We say that at z equal to 0, this function have a zeros of order 2. Why the zeros of order 2? Because second derivative does not equal to 0 and all previous derivative f dash 0, f0 equal to 0 at z equal 0. Now if we try to write in this form, this one is a by the definition of this one, f z0, f dash z0, f double dash z0 up to fm minus 1 z0 equal to 0 and fm z0 does not equal to 0. In this case, what is the value of m? The value of m is a 2. The value of m is a 2. So what is the order of a zeros? So this is here, order of a 0 equal to what? 2. Now we try to write in this form. What is the value? Here we erase out this one. And here we write fz equal what? Fz equal alternate solution. This one is a alternative solution. We write a alternative solution. Yes, sir. In this way also we able to decide. Now fz equal in this way also we able to decide. Fz equal what? Z into e to power z minus 1. So if at z equals 0. So at z equals 0, what will happen? If we write here fz equal z minus 0 e to power z minus 1. So if you compare here, this one is a zeros of order 1. Provided what? Provided z0 does not equal to 0. But here, what will happen? C0, if you put z equal to 0, this become what? 0. So here z0 does not equal to 0. So you cannot write this form. So this one is not a correct one. This one is not a correct form. Why this one is not a correct form? Because here z0 does not equal to 0. It must be necessary if we write in this form z minus z0, z0 must be equal to 0. So if we write fz equal what? Z minus 0 square e to power z minus 1 divided by z. Then this one is a what? This one is a zz. And this one is z minus z0 whole square, z minus z0 to power m. And here what is the zz? Zz is a e to power z minus 1 divided by z. And here z0 does not equal to 0. Why? Because e to power z, if we expand e to power z minus 1, then this become what? Then this become 1 plus z square by 2 factorial 2 up to infinite number of a term minus 1 divided by z. 1 and 1 cancel out, and if we take outside the z, then this become 1 plus z upon factorial 2, z and z cancel out, then here this become 1 plus z upon factorial 2 up to infinite number of a term. This means z0 is a what? Z0 is a 1. So z0 does not equal to 0. So this one is a correct form. So if we compare with what? If we compare with the standard result, means fz equal z minus z0 to power m zz, provided zz0 does not equal to 0, then what is the order of our zeros? Order of a 0 with the m. So here, if we compare this one, then what is the value of m? The value of m is a 2. So what is the order of our zeros? So order of a zeros is a 2, because the value of m is a 2 and zz equals this one and z is 0, at which we try to find out the order of our zeros. The function z0, gz0 does not equal to 0. So either we write in this form or with the help of this one, in a both way we decide what is the order of a zeros. Later on we try to link the pole and or zeros. Means how we define the pole with the help of a zero. That's why here we define the, first we define the zeros. Now next we define